evening. It's 7:05 in the evening here now. Been a while since you saw this ugly puss on my channel here. I got Bob's radio back up on the bench here. I received a call this morning from Bob, and he got the number 47 tube, 43 rather, number 43 tube in the mail, and he got a ballast, but it's not the same number, so it says it looks the same outside, but we'll find out. I'll have to measure it, and I have no idea if it's even going to work. I still didn't get the capacitor in, but I want to show you some things that I've done on here. I ground off the speaker. This is what's left of the moving vane speaker. And I literally took it all apart. It had 4 bolts in it, about 1 inch long, with the nuts. And some of them I used to mount the new speaker with. Because when it comes to nuts and bolts, besides being nuts up here, I have a mixture, but I don't have what I had in my old shop. I have like a 2-gallon can of all kinds of nuts and bolts that I was never able to get them back over here. So I have to scrounge around to get nuts and bolts to replace the rivets for the speaker. So I want to show you right now what I did on the radio and what has to be done. Okay, I removed drilled out the rivets, and removed the capacitor block. It appears to be tarred in there. There's no values on here. It shows you capacity, it gives you voltage. But the schematic says 30 microfarads and 10. Over here in 24 and 10. So I got a 33 in here. So what I did here is, I was going to put this back in, but the nut and the bolt sticks out too far, and I couldn't get this back in there because it would be away from the chassis. So I decided just to get rid of it, take it out completely. And here I got a 10 microfarad and a 33, both at 160 volts, put a terminal strip in there, and ran a couple of red wires over to where the other ones were that went to that electrolytic, and the 1,000 ohm resistor. It basically goes on each side of the 1,000 ohm resistor. And the electrolytics go right to the chassis. Here's the ground right there. You might be able to see it. See that black wire soldered right to the chassis right there? Okay. And I clipped it off the capacitor block that was here, and I just tacked on another piece of wire and brought it over to the ground terminal of the strip here, and put my 2 negatives down to that on these for these electrolytics. Now, the chassis itself is not only the B minus, but it is also the negatives, the neutral side of the line. On the power switch, one side, the terminal nearest the camera, was connected to ground. I took that ground bond off, and the other wire goes all the way around and up here to this terminal number 1. No, yes, it's pin number 1 of the ballast tube. But I still don't have a pin out of the ballast, so I don't know what's what, and I'm going to have to stumble around with that. So I'm going to have to make some wiring changes here, because this wire is no longer going to the chassis by way of the switch. It's simply going to be in series with the ballast now, which will be in series with the line, and it'll be the hot side of the line which will be switched. So when the ballast comes in, if I can use it, I'm not sure what the voltage drop is on the ballast he's got. He gave me the number, but I didn't try looking it up, and I'm not too successful with looking things up anyways, especially with ballast and so forth. I can't really get much information out of it. So if it don't work out, I'll just use the capacitor like I was originally going to do. Now the speaker, you can see I've got the speaker with the 3 bolts. There's 2 here and 1 down and back of the capacitors. You can't see them there. And on the front, I've got the cardboard to keep from knocking holes in the speaker. And I got the red with a piece of heat shrink on it. These 2 terminals give me a couple of ohms more of DC resistance than this to this. And I think from this to this was 3.2 ohms, something like that. So I picked the one that had the highest DC resistance and used those 2. Okay, so what I'm doing here is essentially bonding this down here. Disregard this field coil does not exist on this radio. So basically it just grounds right here. As I said, these upside down antenna symbols are really the grounds. Yeah, and the ground on this particular radio is the chassis. There is no B- floating with chassis ground being separate. The chassis is one side of the line. In other words, it's an electrocution radio. If it's plugged in wrong and you get your hands between it and a ground supply. So basically, I'm eliminating the switch here, and I'm going to be putting the switch in here. So one of the wires that's already coming off the switch and going to the ballast will have another wire coming off of the other side of the switch and going to one side of the hot side of the plug, which will be a polarized plug. But I still need to know the pinouts for the ballast. And if the ballast Bob has, he's going to meet up with me Monday morning at Old McDonald's farm, along with the, he's going to bring the 43 tube. And if the ballast works out, I can wire it in to get it to work, but I don't know what the DC resistance is of the ballast. The schematic tells you nothing here. It just gives you a ballast number, which could very well be that ballast. It may not be, because there are differences in this schematic, as I said before. So, as I said, this is the condenser block, which I was going to put in for cosmetic reasons, but because I got the electrolytic and the terminal strip in there, I'm going to just, give it to Bob, and he can throw it out or whatever he wants to do. The same with this stuff here. He's not a bit concerned about getting rid of the moving vane speaker. I had to grind it with the Harbor Freight. I had nothing else. My Dremel tool does not have a metal cutting wheel on it. I don't think any of them do, or you may have to buy them separately. So, but the Harbor Freight did it quite nicely, and it didn't damage the chassis. I had to do it from the outside because I couldn't get my drill in there, in the back of the chassis. Not without, because of the back apron of the chassis. Because of the back apron here, I couldn't get in there, and I would be busting up components trying to jam it in. So this is what it is. There's a piece of insulating material here. The 400 ohm coil, which I could try my inductance meter on now. Supposedly magnets, but they're very, very weak, and it's steel. I don't think they're iron. I think it's steel. And some more of it here. And a piece of what looks like stainless, and another piece of metal, and the moving vane portion, which, as you can see, was patched up and so forth. So I'll just throw these in a baggie and you know, Bob can do what he wants. He just wants the radio working, and he doesn't even care if the pilot light works or not. If I have to use the capacitor, I won't be able to get the pilot light to work unless I put a neon bulb in there. And if I put a neon bulb in there, I got to put not only a drop-in resistor of a larger value, I have to also, not a neon bulb, an LED, I'm sorry. You need a diode for rectify, because a diode isn't going to run on AC. But those pilot lights that I put in the S86 will run on AC, so they obviously got a rectifier in them. But it would need a dropping resistor to go down to the, probably on the hot side of the switch. So in other words, I'd ground one of these, one side of the LED to the chassis, and then through a resistor, which I'll have to experiment with, and try a very high value and keep going down until I get the light the way I want it, and check the voltage across the bulb, because forget math, I can't. And not only that, but we don't know how much current the LED bulb takes anyways, without looking it up, and that's time consuming. So I can always do that if I have to use a capacitor. If I use the ballast, Bob said that the ballast that he got from eBay is made for a 51 bulb, but I don't know about the voltage drop. He mentioned something about 90-some volt drop. I need a 49 volt drop on this. So that may not work out. I may have to use the capacitor. The capacitor may or may not fit here, but I can put it on the top of the chassis. That's not a problem. So that's the story there. When Bob called, I got this out, and I said I'm going to cut this speaker out of here and get the one he brought to me in, get the electrolytics in, and basically now the only thing left to do is to find where that wire broke off on that coil underneath, which I showed you in earlier videos if you've been watching them, and get the ballast or the capacitor in there, and I think the radio will be all set. Whether it works or not is another story, but time will tell. Okay, so when I get this radio done and back to Bob, I'm going to pull the S86 on the bench, and I'm going to take and short out the antenna. I'm going to put my scope on the IF cans, and I'm going to see if I get any noise, because no antenna coming on. Sensitivity will be all the way down when I have it on the bench. No antenna. The speaker will be connected, and the oscilloscope will be probing around the IF cans. There's 3 of them in there. In addition to that, I'm gonna use my signal tracer, but the only thing is I don't have an RF probe for it, so it's only going to be good for audio. So I'll be able to read from the audio input grid back to the speaker, of course. I don't have a RF probe or detector probe for that. And it uses a 1N48 diode, which I don't have. Now, speaking of probes, this meter here came with an RF probe. Okay, this came with the Motorola DC meter that I just showed you. It's an RF probe. It uses a miniature BNC plug, and it goes up to 400 megacycles. You may or may not be able to read that. And what I'm going to do is I'm going to open this thing up. It's relatively easy.
Okay, I'm going to open this up It's a little hard for me with my bad eyesight putting the screws back in here again. Get a small screwdriver here. Alright, the clip comes off. There's the clip right here. And there's a screw. You just take this screw out here. Now this probe might work on the signal tracer, but I'm not going to go cutting the plug off of it. Make sure I'm still on camera here. Alright, so this is the probe tip. And this is the body of it. And if I can get a magnifying glass and maybe you can read that. In case you can't, I will try. Find my magnifying here. Gotta get something. Okay. This is made for this particular model Motorola meter. Model S1052B, which is what that is. The frequency range is 1 kc to 400 megacycles. The maximum DC voltage is 400 volts. Maximum AC voltage is only 10. Okay, it says right on here. Okay, here is the probe. And why I'm opening this up is because, according to my digital meter, this diode in here is open. And let me see if I can find a diode here. Diode's right here. Right above the yellow capacitor. And, of course, if there's a number on it, I can't read it. There is no book on this Motorola S1053, or 1052, rather. Meter. You cannot get a service manual or a manual on it. So that would have given that information as to the diode. The diode is bad. The capacitor, the yellow cap in here, is a 0.0015 microfarad. And the resistor that's in here, I got to get my eye lope, is 3.9 meg. 3.9 meg. So, this probe does not work because the diode is bad. The 3.9 meg is right on the money, and as close as I can test with my capacitor checker, the capacitor is right on. The capacitor goes in series with the probe tip. The diode is connected to the shield, or the grounded side, and the other side of the diode is connected to the other end of the capacitor right here, and where the junction of the resistor and the capacitor meet. And then they both go into the probe right here. And, the capacitor is in series with the tip. This is the tip here, okay? The capacitor is in series with the tip. Then, at the junction of the 3.9 meg resistor and the 0015 capacitor, the diode is here and it goes to the ground. And the band of the diode goes right at the junction here.
So, I'm going to bring this over and hopefully I run into Mike tomorrow. And he said it might be, you could probably try a WinN 914. Well, I ordered some. They're only $1.69 for 10 of them on eBay. I ordered some. Big time spender here, you know. In the event that it might be. But I was also told it could be a Schottky diode that's in there. I have no idea. But whatever diode's in there, it's got to handle 400 megacycles. And the WinN 914, I think it only will handle a max of 100 volts. So it's telling you 400 volts DC, but this is the blocking capacitor, so there won't be any DC on the diode. And AC, it's only good for 10 volts. So if you're checking a high-frequency AC circuit, you better make sure it's under 10 volts. And that's probably why the diode blew, because somebody probably put too much AC on it. It could have connected it to the line for all I know, and blew that. You're not going to hurt the 3.9 meg resistor or the capacitor, because this capacitor is rated at 400 volts also. So anyways, I'm going to leave this apart because I'm going to show Mike and see if he got any other suggestions, because he could literally design this thing. I mean, you know, he was willing to calibrate my meter for me here on this one, but I don't think this needs calibration. But he might have a better suggestion than the 914, because I didn't have this with me at the time. So hopefully he'll be in tomorrow and I'll be able to do that. So as always, another long-winded video. I can't seem to keep them short at all. Alright, so thank you for watching. And when more comes on this radio, when I get the rest of the materials, I'll be doing some more video and I'll show you what I've accomplished, and I'll let you know if it's working or not. Have a good night, everybody, and take care. Have a good weekend.